Okay, so can I ask you, before I introduce what we're doing today, can I get you just to add these two algebraic fractions? So this is using the second sort of half of the lesson the other day. Can you add those two fractions together for me? So we're looking for a common denominator. So are we comfortable with the idea that we are skipping sort of a step? So rather than writing this as a fraction with the same denominator as this, I've sort of gone straight to that. And yeah. Now I'm assuming you're all familiar with the hokey cokey, where you put something in and then you take something out. And in maths we often find that we learn how to do something and then we learn the reverse. So for example, we learn to expand fractions, expand algebra, and then we learn to put brackets back in. Or we learn to differentiate, and then we learn to integrate. Now, of course, in the hokey cokey, we then shake it all about, so that the analogy breaks down at that point. But we have a reverse process for this. So here I've taken two algebraic fractions and added them together to get a single algebraic fraction. So what we're going to do today is learn how you go from this back to this. Now at the moment it's not particularly clear why we bother doing that, because it's to do with something we learn later on in relation to integration. So it's just one of those skills for the moment. I'm going to have to say, right, sit tight and we'll, the reason for it will become clear. It's a process referred to or called partial fractions. So it's taking one fraction and breaking them down into separate fractions. We'll start with just two, but there are some examples where we have more than two fractions. Partial fractions. So let me give you an example of the sort of thing that we might want to separate into partial fractions. So I've got the same denominator that I started with a moment ago. And so this is the answer, and what I need to do is to split it up into the two fractions it came from. Now the first thing to note is that it is not obvious. If you look back at the previous example, we had numbers over x minus 3 and x plus 1, which ended up giving us algebra over x plus 3, x plus 1. So the answer certainly isn't going to be 6x over x minus 3 minus 2 over x plus 1. It's going to be more complicated than that. However, there's one thing I can tell, and that's to do with the order of the expressions. So if I look at this, I've got a fraction where the order of the numerator, the highest power of x, we call that the order, is 1. And if I was to multiply that out, the order of the denominator would be 2. Highest power of the denominator would be x squared. So I've got something where I've got order 1 over order 2. The order of the top is less than the order of the bottom. And as long as I've got that, I know it's going to separate out into separate fractions where I've got a number which might not be an integer, but it will be rational, so that means I can write it as a fraction, over x minus 3, and a number over x plus 1. Is it any pigeonholes there? Yes, thank you. So the order of this is 1 less than the order of this, and that means when I separate it out into separate fractions, the order of this will be 1 less than the order of this. This is just going to be a number, and we say that's order 0, no algebra at all. And so what I need to do is work out what A and B is. And there's two processes, there's two ways of doing it. I'm always a bit torn about which of the two ways to choose, so we'll do a little bit of both, all right? So we're going to start off using a process called equating. We've come across it before actually, but and equating, as the name suggests, is something to do with this sign here, and the fact that the thing on the left is the same as the thing on the right. So what I'm going to do is I'm going to pretend, this is not good for videoing, I apologise to Jody. Oh, it's beginning with J. Jody, James, James and Joe.
Wow.
Hang on a minute. We're okay, right, yeah, that's good. Yeah, so I apologise, Mr. Bright is giving a particularly good vocal performance out on the Astro, so I apologise if you can't hear what I'm saying. Yeah, I'm going to pretend that I'm being just asked, I'm just being asked to add those two fractions together, so I know that I'm going to get a times x plus 1 plus b times x minus 3 over. So that's the process we just went through in the one at the start. We know that those two fractions will give you a common denominator of that, and to turn that into that I need to multiply by x plus 1, so I do the same to the top, and to turn that into that I need to multiply by x minus 3, so I just do the same to the top. And, you know, so I'm saying that this is now the same as this. Could anyone suggest what I can now do to make it all very, very easy and happy and straightforward? Remembering how I feel about fractions? Yeah, so I can multiply both sides by x minus 3, x plus 1. Which means I'm left with, on this side, and I'll be honest with you, when you get confident with this, I suspect you will go straight from there to there. I suspect you won't feel the need for that intermediate step, because you'll just be confident, all right, I know my denominator is going to be the same, so I can just worry about the numerators, because I know at some point I'm going to be able to do that step, and it's all going to be done. Right, so what I now do is multiply out my brackets. And now I do this thing called equating. And the equating process says that equal sign tells me that this has got to be the same as this. And what that means is, because I can't combine these, this is algebra and these are numbers, that means that the number of x's on both sides must be the same, and the numbers, I'm going to call them constants, the constants on both sides must be the same. So on the left-hand side, I've got 6 x's. And on the right-hand side, I've got a x's and I've got b x's. So I know that a plus b has to equal 6. I don't know if the bottom of the board is visible here, so. Yes, it is, that's good. So looking at the constants, I've got -2 here. This is just the things without algebra. So -2 there. And I've got a, that's a number, there's no algebra there, and a -3b. Simultaneous equations. Yes?
How did you get to just the 6?
Because that's just the number of x's. Okay. So I'm just asking, what I'm asking when I equate is how many of these have I got? So I've got 6 x's on the left hand side, and I've got a x's and b x's on the right hand side. So it's just a, so go on, see if you can solve those simultaneous equations. I mean, I would just whack it into my calculator, put my calculator into equation mode, simultaneous with 2 unknowns. It only knows about x and y. I've got a and b, but it's the same thing.
So then we're doing it through simultaneous equations.
Well, yeah. I mean, you could do it manually, but yeah. So if you want, but you can. So are you familiar with doing that? So menu, equation, simultaneous, and 2 unknowns, and it's expecting it in the form ax plus by equals c. So you need to do, I've got 1a plus 1b, so that's 1 equals 6, and I've got 1a and -3b equals -2. So that's how you type it in on the calculator. So do we get an answer? What do you get for A is and B is? So you get A is 4 and B is 2. So what we then can say is, okay, my original fractions would have been and actually I've run out of space, but I would probably sort of restate that at the end, or it might just say what's A and what's B. Now, that's one of the 2 processes. It's the longer of the 2, but I think it's the more straightforward of the 2. So we're going to do both, so you can make a judgment. So can I get you at this point to have a go at page 11, question 1b. Page 11, question 1b. This is actually 1a that we've just done. Using that process. And then we'll have a look at the second process.
So all you need to do is find A.
That's correct, yes, that's correct, yeah. So we get A is 3 and B is -1. So that means I could write it as that. But actually it probably looks nicer if we write it like that. So actually it's a subtraction sum rather than an addition sum. Yeah, okay, good. Now, if you started E, then leave a bit of space to finish it off. So with E, so Grace, could you suggest what I need to do to E before I do the partial fraction process? Yeah, so the denominator in E I need to factorise first, and then I can split it up into my two separate fractions. So I'm going to show you the second method now, but if you started that one, then by all means finish it in your own time. You should get A is 2 and B is 4 if you carry on with that one. Sorry to spoil the surprise, but just to double check you can. So that's just slightly different, isn't it, with E, where it doesn't look like this, so we have to do a little bit of work first. Okay, can I show you the alternative technique then for doing this? We've used equating now with a couple. There's an alternative technique. Let's use D as an example. So D on page 11, question 1D. We use that as an example of the second approach that we can use as an alternative to equating. Oh, is Beth isolating as well?
She was in yesterday.
Oh, anyway, it's all good. Videos there for everyone. Yeah. And even for you, if you. So we've got 2x minus 13 over 2x plus 1 and x minus 3. A bit more complicated, 2x plus 1, but it's still order 1. So I've still got something where the order of this is 1 less than the order of that. So I still am confident that it's going to go like this. And the first step, just the same. So I know that to get a common denominator, A needs to be multiplied by x minus 3, and B needs to be multiplied by 2x plus 1. And I've skipped the denominator step altogether. You know, there was a denominator there, and now I've multiplied both sides by 2x plus 1, x minus 3, so the denominators have gone. So the method we can use instead of equating is called substitution. And all I'm going to do is substitute a value of x into the equation. So I'm going to make x equal to 3. Could anyone suggest why making x equal to 3 is a good idea?
It makes that one equal
So
0.
it cancels out the first.
This disappears, doesn't it? Yeah. So I'm going to make x equal to 3. If x is equal to 3, then that gives me 6, take away 13, which is minus 7. 6 take away 13. Yes. That becomes nothing. A times 0 is 0, and this will become 7b. So I know b is minus 1.
That's quick.
I did suggest that it was quicker. Yeah. I'm pleased if you are relaxed about it. So what's the second value I'm going to use?
How are you allowed to just substitute?
Well, x is a variable which can be any value.
Okay.
Now, actually, this is a cheat, because what would happen to my original fraction if I made x equal to 3?
It'd be divided by
Be divided by 0, wouldn't it? Yeah. So actually, it is a bit of a cheat. It is a bit of a cheat. But it is a cheat we're allowed to do. I mean, x is a variable, so I can make it any value I want. But yes, we are bending the rules slightly. So what's the second value, Charlie? What's the second value I would substitute in? 3 was a nice easy one because it would make that bracket 0. Yeah, minus a half. Minus a half, because if x is minus a half, 2 lots of minus a half becomes minus 1 plus 1, 0. So my second value is minus a half. So Little bit more complicated maybe. So my left-hand side is going to become -1 minus 13, that's minus 14. That's going to disappear. And my right-hand side will become -1/2 minus 3. So that's 3.5, 3.5. Sorry, minus 3.5. So minus, sorry, I'm writing on wet board. Then, so minus 14 equals minus 3.5a. Is that 4? Yeah, 4. He says nervously checking the answers. Yeah. So A is 4. So going back to my original question, A is 4 and B is -1, which we could write as +(-1), but it's probably easier to write it like that.
It's weird how this works.
Sorry?
It's pretty weird how this works.
Well, what you've got to realise is we're not substituting x is 3 into the original fraction. We can't do that. But because we've used correct algebra to get to here, there's nothing wrong with making x equal 3 in that. So x can't be equal to 3 here, but it can be equal to 3 here. So it's, yeah, we can't, we could substitute x's any value in here, but except for 3 and -1/2. But having gone through the algebra process to get to this, which is completely correct, we can now choose any value we want. Yes, Will?
How would you know what values to substitute?
So it's the solutions you get from those brackets. So you've got to ask what value of x would make the bracket 0. So if x is 3, 3 minus 3 is 0. And if x is -1/2, 2 lots of -1/2 plus 1 is 0. So that's what you're looking for in each case. So have a go at f using this process. F is one where, like E, you've got to factorise the denominator first. So once you've factorised the denominator, and it's not a complicated one to factorise, but once you've factorised the denominator, you then can go through this process and try and use substitution to do that. And then once you've had a go at that, have a go at number 2. So we're doing 1f and then question 2, both on page 11. 1f, question 2. 1f you've got to factorise first. Yeah, so when you're given one that you have to factorise, who's to say which way round you're going to do this? Doesn't matter. So we may well have our a's and b's the other way round. The other question someone's asked is, that's a negative, so do I need to put a minus there? Well, you don't need to. I default to a positive, and that just means if I end up with a minus value there, then I just change it then. If you do put a negative there, you'll end up with a positive here. So it does all work out in the end. So the final answer you should have got is -1 minus 2, or -2 minus 1 if you put your brackets the other way around. And that's why in question 2, if you've got onto question 2, they give you the way they want it. So they want it as a over 4 plus x and b over 2 minus x, just so it's easier for them to mark. There's no other reason than that. And if you have, I've lost my mouse, can't find the mouse. I'm just looking at the answer to number 2. Got onto it. Oh, now 2 is the first one where you get fractions. So a and b don't necessarily give you whole numbers. A is 1/2 and b is -3 over 2. And that's interesting actually. So you could write that in a number of ways. So if you haven't done number 2, I suggest you have a go at that in a moment. So you end up with a is 1/2. And b is -3 over 2. And that's fine to leave it like that if you wish, but we could, so this is the answer to question 2, we could write that differently. We could write it as 1 over that minus 3 over that. Those are the same things, because what we're effectively doing is 1 divided by 2 and then divided by 4 minus x, which is the same as dividing by 2 times 4 plus x. And here we've got 3 divided by 2 and then divided by 2 minus x, which is the same as that. So it is perfectly possible to get partial fractions questions where you get fractions as your answer. If it just says what's a and b, then you're fine. A is a half and b is minus 3 over 2. But if you then have to write the expression, then there we go. Okay, how are we doing for time? Just want to check we've ready. Yes, plenty of time. Okay, could we have a look at question 4? Question 4 is more complicated, obviously. We've got 3 things in our denominator. So I'm now on page 11 still, question 4. And for those at home, I have emailed you a PDF of the textbook, so hopefully you're able to follow this. I know that may mean having a couple of screens open, but you're all young techie people, I'm sure you can cope. So we've got a triple denominator and we've got a quadratic on the top. But let's just check. Do you remember I said as long as I've got an order on the top that's less than one less than an order on the bottom, I'm going to get single fractions where the numerator is a number, and that's what I've got. Top is order 2, 2x squared minus 12x minus 26. And the denominator, if I was to multiply that out, would have order 3. So I know that this is going to give me still the same thing, but I'll just have 3 answers. So I'm going to throw in a C there. Now this next step is a little bit more involved. I want a common denominator, so I'm not going to write it as individual fractions, but if I wanted this fraction to have the same denominator as this fraction, I need to multiply by this and this. And if I multiply the bottom by that, I'd have to multiply the top by that. So my top is going to become and to turn this denominator into the same as this denominator, I would need to multiply by an x plus 1 and an x plus 5. Well, that's okay, as long as I multiply the top by an x plus 1 and an x plus 5. And for C, to turn this denominator into the same as this denominator, I'd have to multiply by an x plus 1 and an x minus 2. So I need to multiply the top by an x plus 1 and an x minus 2. So basically, hopefully you can see, you need to multiply your numerators by whatever you're missing in the denominator. So I've got an x plus 1, but I haven't got an x minus 2 or an x plus 5. Bang. I've got an x minus 2, but I haven't got an x plus 1 or an x plus 5. I've got an x plus 5, but I'm missing the x plus 1 and the x minus 2. So I've still skipped. I could have done that with a denominator underneath, but the first thing I would have done would have been to multiply the denominator. So I'm hoping you're comfortable about that. So Lily, what am I going to do now if I use substitution? How am I going to cope with the fact I've got 3 missing values? What values am I going to substitute in? Well, what value of x would make that bracket 0? Minus 1, and then, so I've got 3 numbers to substitute in. Now you've got to be a little bit careful. I'll start you off. So if I use substitution, I'm going to make x equal to -1. That would mean that that bracket would become 0, so that whole term would disappear. And that bracket would become 0, so that whole term would disappear. So I'm just left with this term. So I'd have to work out what I've got there. And I've also got to substitute x is -1 into that, so it's a little bit more complicated. I'm trying to catch that. And then once you've done -1, do 2 and -5 as well. So it's a little bit more involved, but hopefully you can see it's still a lot easier than equating, because with equating I'd have to multiply that out, multiply that out, multiply that out. You can do it, but it's more complicated. So I've substituted in -1. I used my calculator to work out this using the x value, 2 and -5. So I get my values: a, b is -2, c is 3. Again, notice that in an exam they would give you the framework. They told us which order to do it in, otherwise it'd be a nightmare for them to mark. So I can then rewrite my answer. A is 1, b is -2, and c is 3. Good stuff. Right, we'll do another level of difficulty next time. I think with so many people away, I'm not going to go through those exam questions tomorrow. I'm going to carry on with this. But if you've already done them, well done. We will go through them whenever people are back.